lot of new things to cover, and actually, I don't know if it's legible, but the stuff in the back is not a random graphic. It is actually a whiteboard, and
we like whiteboards, you know that.
Yeah, no, absolutely. I had a real picture. This thing's kind of washed out. But the funny part about this whiteboard was, this was everything that was written on the whiteboard throughout the FPP 1.0 development process. Because like 3 months after we started the company, we lost the eraser, and,
and
the guys kept going anyway, right? And so then we had a gobbledygook of things, and I can actually make out what thing is what. But yeah, it evolved to be a very fun whiteboard. If you could make out what is what, then you literally have the keys to the magic kingdom. But
not really.
Still have that whiteboard somewhere.
Anyway, so we are going to talk about a few things now, which we did in the interim. But before we go there, let me talk about where we want to end up as a company with this product. And so our goal is to actually bring a lot of storage intelligence to the server side. And actually, well, Enrico just stepped out, but he called it out first, and he should get credit. I think it was November 2013 when he actually published an article about server-side caching. Is it a holy grail or a mere feature? And he hypothesized that if this can be done right, then we were talking about you, Enrico, by the way. We were talking about you.
You're getting a shout out.
Yeah.
The bottom of the screen.
Pulling a Chris Wall on us.
So I was saying this is where we want to take FPP to, and it is going to be a journey. We are doing what we do very, very well, but we are going to build in various other things that hopefully you didn't see coming. But well, Enrico saw it coming. Is in November 2013 you wrote a blog post about whether server-side caching is just a feature or a holy grail, and you theorized that maybe if it's done right, this can actually evolve into a resource management layer, and which does policies and much more than just caching, and that is exactly what we are going to do. And so to that end, let me first present some evidence as to why we are going to end up there. But before I present the more kind of more evidence to this fact, first things first, right, is tie your shoelaces. And so it is well known that we currently support all blocks data stores as acceleration capable. We don't support NFS. So the first thing we are now able to do is we are able to accelerate NFS data stores, and I'm going to show you a demo in a second. Yeah. But the highlight of this thing is, when we created PernixData and we created FPP, the idea is that FPP belongs to every data center that is running a shared storage system. And well, it turns out that 30% of shared storage systems are NFS. And so, before I paint you the bigger picture, we have to do first things first is actually open our business up to that 35% of the market or whatever it is. And so we are opening our business to that huge market that exists. And so once we do NFS, and this is just a tech preview, I'm not going to promise any dates, etc. I'm going to show you some stuff anyway. But once we do NFS, we would have pretty much covered all types of storage technologies that can run virtual machines. And so anything that you care to have in terms of a storage system, the chances are that we can accelerate them. Whether it's a Dell Vertex kind of system, which is local storage, local shared storage, or it's a fiber channel or iSCSI system, or if it's a NFS system. The interesting thing about NFS is, well, we do what I just told you we do, is we get into the hypervisor and get into the IO path and accelerate it. And so the most interesting thing about NFS is that we have been able to do NFS without doing a virtual appliance. We have been able to do NFS without changing the networking configuration of a host. And we are able to actually take control of the NFS data store without changing the networking identity of the NFS data store itself. And so this will become apparent in this other demo. I'm calling it the Seinfeld demo. And after we see the demo, it'll be hopefully apparent as to why it's called the Seinfeld demo.
Because it's about nothing.
Exactly. You got it. But there's a lot of work required to make it about nothing.
And nobody said nothing was easy.
Exactly.
15 years. in fact.
So here we have a cluster of 3 nodes connected to a NetApp NFS system. So here's the data store. It's NFS3 protocol. That's the IP address 1024.140. And it has 3 hosts connected to it and 3 virtual machines on that data store that are eligible to run. So again, I'm showing the IP address. Here's the host connectivity. Hosts are called 20, 24, and 25. And so there's 1 powered on virtual machine, and there's 2 powered off virtual machines on that data store. So we go home, we go to the PernixData FEP tab, we click on FEP clusters, and I've already created a FEP cluster which has flash devices across all those 3 nodes for maybe an aggregate capacity of around 315 gigabytes in all. As you can see, 3 nodes connected to 3 flash devices. Currently, there are no virtual machines added to the cluster. There's no I/O activity going on that cluster. Here's the 3 flash devices. As you will see, they all come from different hosts, but they are all aggregated into this one cloud of flash across hosts. So the first thing we do is we'll add the entire NFS data store into that flash cluster for it to be accelerated. So here's an Nexenta data store, here's another NFS data store. So the only change that happened to the FEP UI is, as you were able to see VMFS data stores, you see some new kids on the block, which is your NFS data stores. And so, bam, that's it. You added your data store. Every virtual machine on that data store is now accelerated. We only have 1 powered on, so obviously at this point in time, that 1 virtual machine is accelerated. Any new virtual machine that you add to that data store will obviously also be accelerated. And so we visit the UI a little later, and you see there's some activity on the data store. The virtual machine is on. And so now I want to show you, go back to the data store pane, and we will see that the virtual machine is on. It is being accelerated. But we will see that there is absolutely no change that has happened to that physical configuration of the data store. And so here's the 3 VMs as they were on the NetApp LAN. And if you go to manage, then the LAN is still connected to the 3 hosts with the same IP, and the device packing has the same IP as well. If VMware had a better view of network topology, I would have wanted to show you the network topology to prove that nothing changed in the network. We'll have to take my word for it. Let me close the button to sound more credible, but nothing changed. Network, So anyway, jokes aside, no VLAN configuration changes, no this is configurable with whatever technology you have, whether it's a distributed virtual switch or a local switch, whatever. Any questions?
So write through, write back, and all that stuff is...
Yeah, every feature that FEP already supports, write through, write back with fault tolerance, it's all supported.
It's all supported, and those would all be defaulted to some configuration level default for this environment? Because you didn't turn any of those on as far as I could tell.
That is correct. So I guess in this demo, we added the data store into this flash cluster in write-through mode. So I guess we missed seeing that write-back configuration turned on. But when you add the data store to the flash cluster, you are able to choose what is the degree of replication that you want. And so that's one thing that we miss seeing in this demo. But one of the other demos will show you that.
So here's a stupid question.
Mm-hmm.
Could I plug in some flash appliances and use them as the flash pool to accelerate other legacy SAN?
Could you plug in some flash
instead
appliances?
of putting flash into all of my different VMs and servers, which I have to reboot to do,
Yeah.
could I just plug in a flash appliance to use as an acceleration store, possibly 1 or 2 of them, so that I have redundancy, and then use those as the target for that write?
Could you plug in such a flash appliance? Actually, the answer is yes. Now there is one gotcha, right? Which is, and not necessarily or gotcha, but because now you are accessing a flash appliance, now all our acceleration traffic is actually going to go over the network, excuse me, to that flash appliance.
Yep.
So it better be sure that that flash appliance and the network is actually able to take that. The latencies will obviously not be the same as
Might be
local
that good.
latencies.
And I can see that as an easier deployment method than having to evacuate all of the VMs and fail over for certain customers.
That and if you have a single very high priority application, you could buy a Pure or another all flash array, put your ERP database on the all flash array, and then use slices of it to accelerate everything else via an acceleration layer like FVP.
Or you could just use the one that Violin have got, which just does that transparently for you. So you wouldn't even have to reconfigure anything, because it would just spoof that I/O and do it in memory. The memory appliance, whatever they call it.
Yeah, they are not. They haven't developed that in years. I would.
No, they redeveloped. They re-released it as a product. Talk about it separately. Talk about it later.
So the other answer I want to give to your question is that so you brought up the convenience argument, right? Is that it's convenient to use this box. You keep on adding, deploying more flash to machines as you see fit, and that is true. But I would also argue that flash technology in servers hasn't matured to where it actually needs to be, and it hasn't because the use for server-side flash was very limited. And so with something like FVP, we are going to change that. And if we change that, then the real question is, will that technology now get to some maturity level where adding new flash to the server is not as painful as what you were saying.
Not just that, but also removing and maintenance and that
exactly.
sort of thing. So
right.
that's still bedding down on how we sort of went there and then we went away from that, and we have dedicated appliances for that reason.
Right.
So I can see it as a stepping stone. And again, this is not something that would be used by many customers.
Right.
And I've seen some questions from Twitter about, well, wouldn't you just evacuate the host? It's like I've had some customers who didn't have spare capacity, and procuring another server that would get the spare capacity to go and do this was going to take 9 months.
Well, that's just bad
So they
cluster
can't
design.
update.
Oh, yeah.
Well,
How do they patch?
Restart during updates.
How do they don't patch?
Agreed.
Yeah, that's dumb.
Yes.
It's,
So, yes.
it's suboptimal.
There
but
were
it
many
happens.
issues with this client, none of which were my fault.
Yeah, but we shouldn't, saddle a vendor with, the
No. I'm
stupid
not,
designs of.
and I'm not saddling the vendor. That's why I said this is kind
Or
of
like
a dumb
expanding
question,
their market,
but
just
it
to
is
complain.
this is something I could put in my tool bag and go into that kind of customer and go, okay, you have a weird problem here. Have I got a solution for you? By the way, we can do this with no downtime.
Yeah.
They will
could see
love
that
me
being very
so much more than they already do.
Do you guys support the Ultra DIMMs and all that?
Actually, funny question. So we do. I wanted to do a little video about it, but unfortunately we ran out of time. So yeah, we do.
Okay.
That's kind of cool.
Yeah, we'll see them Friday.
Right. So anyway, let's see, where were we? Right, so flash technology will, and some of this is apparent to us as we do this PernixData thing, is there are some new design for server-side flash technologies which make them hot pluggable, hot swappable, that kind of stuff. It's going to be fun.
It's getting there.
It's going to be fun, yeah. So the next thing I want to talk about is, we came out of stealth February 2013, which was slightly more than a year ago. It was exactly 1 year after we founded the company, which was February 2012. And when we came out of stealth, this is what our website looked like. Now, this is obvious. We say, well, you're running a bunch of VMs, and with servers plus flash plus PernixData, FVP, you could create a data in motion tier in front of your data at rest tier. And then we left it at that. Is that why would you want to create your data in motion tier? Well, now we know is, we can do acceleration at a crazy, level that this tier can never match, etc., whatever. But, so this was very tactical. But this part was a interesting thing, right? And in fact, it was funny, no one brought it up, is, we said, say hello to a brand new data tier, and no one called it out, and we obviously let it be. But we did, talk about exactly what we are going to talk about now, back then, and people didn't call it out. But we did leave a Easter egg. So to understand what that Easter egg was and why we are going to actually do the things we are going to do, we should understand how this marriage has been done, right? What is this marriage of FAP with server flash in reality? From a technology point of view, what is it that really matters in this marriage of server flash and FAP? So on the server flash side, really what matters, what the server flash piece of hardware brings to the table is that it's really fast and it's sufficiently large. It's sufficiently large to the extent of being able to hold the working set of all the applications running on a particular computer. It's not ridiculously large, like a Seagate disk, 4 terabytes or something like that. It is sufficiently large. So those are the two interesting properties that a server flash device brings to the table. And then it turns out that just by virtue of these properties, the server flash device is totally useless in a virtualized data center. And it's useless because it's a local resource. There's no way to share it. If you do a vMotion, it breaks. There's no way to use it as a write substrate. And so we, as a software vendor, brought 3 of our own properties to the table. And that was us being hypervisor based, us being able to do clustering, and us being able to do fault tolerance. So by marrying something that was ridiculously fast with a hypervisor based IO path, we are able to get the perfect physics for IO acceleration. It can't get faster than this. And we'll talk about numbers in a second. With marrying something that is fast and large sufficiently on a per server basis with our clustering technology, we essentially made a pool that applications don't have to worry about. Is they can consume whatever they want, and we'll figure out what part of the of the actual application is put on what hardware. So that was clustering. And the most important thing is, by actually making this fast and large media and dumb media fault tolerant by virtue of these replicas that we talked about, we made a thing that was just impossible possible, which is write back. So these were the things that we brought to the table as a software vendor to what already exists in hardware. And together, we made something magical, or at least that's my opinion. So let's just talk about 2 boxes, that box and that box. Now clustering, I hope you guys get, is we basically broke down cross-server boundaries. We made a local resource into a shared resource, and that's the end of that. But these 2 things are something that are very, peculiar to PernixData. And so let's talk about perfect physics. Is if you are using a fast medium through the hypervisor. In this graph, for example, I'm showing 4 kilobyte IO that comes out from a virtual machine that hits a local flash device, costs approximately 70 microseconds. And local flash device actually does it in 15 microseconds, but there's a lot of overheads. The same 4 kilobyte IO, if it goes out to an all flash array, it costs 800 microseconds, slightly more than that. And if it goes out to one of the older generation storage systems, 8 gig fiber channel with a lot of NVRAM, that costs a little more than that. And I'm not trying to make any point here, is basically the system is old. They are not using the same generation Xeon processors that these systems are using, and that's about it. But the chasm between the gap between this and that is small, and that gap actually happened because someone used a faster Xeon processor and someone else didn't. Someone used a faster Supermicro and someone else didn't. But this gap is really, really big. And that is the gap of the law of physics. And so this is something that you get because you are not actually involving too many moving parts in the system. Now, I'm fully aware of the fact that there are many vendors who will tell you that, well, if you're going to actually throw in a flash device on the storage side with a fast enough network, i.e. a 10 gig network, you can drive 100,000 IOPS. And that's fine. I never talked about IOPS, I talked about latencies. By involving more components, i.e. the HPA, the network, the storage processor, you can talk about IOPS till the cows come home, but you can never talk about the latency ever being lower. And it is the latency that matters. There is no application in the virtualized world which is wanting to actually do 100,000 IOPS. There are applications in the virtualized world who actually want to do 70 microsecond IOs. And that is the real problem to solve. And that doesn't get solved if you actually move flash further away from the application. The other thing I constantly hear is this thing that, well, if you run the flash so fast on the server side, then you are actually using CPU that might actually be well spent on applications. And that is a thing that is an argument that is used against hyperconverged computing as well.
But you're only using CPU to run the application faster.
Exactly. So Howard just said it is you're using the CPU to run the application faster. But there's an even easier way to put this, right? A very, very layman's thing is that if you are running an application at 100,000 IOPS or whatever, pick your favorite number, 5,000 IOPS, then the argument is that, well, it is better that some storage element does 5,000 IOPS because that way your CPU is free to do the application. So my question is that, well, how are those 5,000 IOPS getting to the application? Isn't the server running CPU to process all the packets that are actually going out to the network to get the damn 5,000 IOPS? And the answer is, well, sadly, yes. And so it is not true that running a faster medium away from the server actually makes the server free of having to spend CPU cycles to make something faster. It turns out you're spending CPU cycles here and you're also spending the CPU cycles there, and that's the bare fact. But anyway, I digress. Coming back to this, my part of the world. The thing I wanted to show out here is that, well, first of all, there is a huge gap made by the laws of physics that already exists between accessing a really, really fast medium away from the application as opposed to close to the application. But the more important problem that we are facing as a storage industry is that this bar is going to vanish to zero. People are already doing things like MCS, which apparently is 15 times faster than the fastest flash device you can buy. People are already doing in-RAM computing, SAP, HANA, that kind of stuff, which is 10,000 times faster than the fastest flash device you can buy. And so what about that? What happens when storage actually evolves to that fast? Then every microsecond starts counting. And the more microseconds you waste trying to get to the media, the less efficient you are running the media itself at. And so that's why I'm really gung-ho about being in the hypervisor and using a really fast medium. But more importantly, being in the hypervisor actually sets us up perfectly for that evolution that is going to happen. Is when this bar goes even lower, us being in the hypervisor gets you the fastest way to get that new generation of media, whatever it is. It doesn't matter. This is the fastest way. Other than, of course, short of actually sticking the media right into the application, which
But you're not going to be a SAP in-memory database.
I'm sorry, what was that?
You're not going to be in there with the SAP in-memory on and all that stuff.
I'm not going to be in there with a SAP in-memory database. Yeah. Hold on to that thought. You just played right into my hand. So, but no, it's a good observation. I'm going to address it later. But hopefully everyone gets it. This is key. This is not a coincidence. This is not some VMware guy is waking up one day and just saying that because I know how to get into the VMware hypervisor, I will. We are there because this is around, and this is only going to get worse. And so it is actually very important for our survival, or for that matter, for the survival of any guy who is playing around with Flash to actually be here. The other thing which is very important for us is to actually prove to the world that fault tolerance can be done on this new set of media. And it's very important because as soon as you do fault tolerance, you are able to do write back on a piece of media that is just not capable of doing write back. And only if you do write back, you can actually run the applications in the world that matter. And so out here, for example, after approximately 6 months of selling FVB, we sent out a survey to our customers. And we said, well, what do you run with FVB? And how do you run it? Do you run it with write through or write back? It turns out that approximately 60% of our customers have 75 to 100% of their VMs in write back. And so that is the amount of faith people put in our fault tolerance technology. And of course, it's been a hard path getting there, but it's great. That was our basic premise, is that if you want to solve the performance problem, you have to solve both the read and the write problem. And now we are seeing data that proves that premise. More than 75% of our customers have more than 25% of their virtual machines in write back. And this is in production. The applications that they run, the majority of our application base is SQL. So this is not a startup which actually hits the VDI beachhead and then tries to grow up from there. This is a startup that goes into your most mission critical workloads. And then we say, well, we'll see you there. Show me what you got. And so that is why we are really proud, is SQL is our #1 use case. Databases, SharePoint. VDI is right here, after web application, after general infrastructure.
This is all production.
I'm sorry?
This is all production.
This is production stuff. This is all running in real. So the point I want to make out here, other than the fact that we are really proud of actually solving a problem for our customers that actually matters. But the technology point I want to make to you is we are able to do this because we are able to do write back, and we are able to do write back because we are able to do fault tolerance. So now if it is indeed the case that fault tolerance is really the tipping point of when a piece of software goes from being niche use case, something that you use for desktops, to a infrastructure level use case, then is it really, is the media type important at all? Is it, other than the basic fact that, we need access as FVB, we need access to a media type that is fast and sufficiently large in the server. Other than that fact, is it important? It's not, because fault tolerance makes sure that that media type is actually, it survives whatever faults that you care to actually, throw at it. The hypervisor stuff makes sure that if the media gets faster, we are there to service that media. So it turns out that the media type is actually not interesting. This could be MCS for all we care. And so that was our message to the world. When we say hello to a brand new data tier, it was actually not about Flash. We could actually very well have just said that, throw in PernixData as software, some fast server media, and we are going to do some magic that you are not going to believe. And that's going to be our data in motion tier. The media type doesn't matter to the extent that maybe the media is memory. And so, for example, you would take a whole bunch of memory from all these servers that you have, ESX servers, and make them into a FVB cluster. And so, for example, in this case, we've done exactly that. Is there's 4 hosts running, and they have, I think it's not obvious in the screenshot, but they're all 768 gigabyte
RAM
hosts.
disk cluster? Is that
Sorry?
what you said? RAM disk cluster?
Yeah, so this is a RAM cluster. This is a FVB cluster made out of all RAM. And so in this case, for example, the FVB cluster has 4 resources, memory from 4 hosts. That is aggregated into a FVB cluster of 1 terabyte that is accelerating 5 data stores and 24 VMs in total.
So you've got 256 gigabytes
per host. Yeah.
Okay.
It could be lower, it could be higher, whatever. But in this case, it happened to be higher.
It doesn't. Is there
doesn't
a
matter.
limit or minimum or anything?
It doesn't matter. So we call this the ability of FAB to actually deal with RAM just as it deals with flash, distributed fault tolerant memory. It's not very interesting that we are actually being able to have memory as part of our FAB cluster. The really interesting thing, the really interesting achievement of this version of FAB is that we are able to make RAM a volatile resource, fault tolerant. And so if one was to make a volatile resource fault tolerant, then you can actually, for the first time ever, have it as part of your storage conversation.
Yeah.
Raise
Problem.
speed.
What happens when an EPO happens and all your little servers go down at the same instant of time? If it's in volatile memory, even though it's been replicated 25,000 times, it's gone.
It's gone, yeah.
A
So
little different than storage. It's not what I'd consider
probably don't want it to
persistent
be-
data. It doesn't actually stay there when
You probably don't want it to be huge then.
I'm just saying.
no, in fact, your point is well taken. I'm going to repeat it because you are playing into my hands again.
Great job, right?
Yeah.
Did you guys
Cutting
work on this
plan.
before the?
No.
we're in
We
that
talked
room
before.
Yeah. I'm going to answer this exact concern of yours in a few slides.
Okay.
But let me just paraphrase what you said, which is a reasonably valid concern, is that if all the servers in your data center were to vanish, then fault tolerance of memory doesn't matter because all the memory vanish. And that's true.
Yeah.
That can be solved one of two ways. One way you can solve it is that you can choose to go flash, which we allow. The other way to solve it is something that I'm going to talk about slightly later.
So are we talking?
Just don't ever reboot.
we talking a multi-tiered cache or RAM instead of flash?
Right. So it turns out you can mix memory and flash.
You
Yeah.
can mix memory and flash.
You can mix memory and flash in a single FAB cluster.
Does it
I
have
guess-
to be the same?
Let me.
Okay.
It doesn't have to be the same size. So
Okay.
you can have different amounts of memory, different amounts of flash from each host that participates in a FAB cluster. You can put in up to a terabyte of memory from a single host into a FAB cluster.
Well, you might be able to, but I don't have any hosts that hold that much memory.
That's dedicated, I assume.
That dedicated to FAB, yeah,
FAB,
for
yeah.
storage acceleration purposes.
Is this dedicated at the hypervisor level? Is it?
This is at the hypervisor level.
So the kernel itself is now consuming. Yeah, you're
That
getting
amount
you're
of
getting
memory.
RAM from the hypervisor structures
Yeah,
themselves. It's not
yeah.
a separate VM or something like that, right?
Exactly.
Okay.
So, and in fact, we'll talk about, what to do when in a second. But, first things first, just the basic specs is that, you can do up to a terabyte of RAM per server. And so in a cluster of 32 nodes, which is the highest VMware supports, you could have a FAB cluster of up to 32 terabytes. Lower if you want. You can add memory after the fact to the FAB cluster, and you can also delete memory from the FAB cluster as and when you please. This is all hot while the virtual machines are going on. And so we figure out how to rebalance the flash footprint, the memory footprint of the virtual machine if you were to take memory away from us, if you need it for other purposes, like running virtual machines. That little thing.
Second
Secondary.
class citizen, yeah.
Yeah.
Well, at some point, you have to balance the fact that the database engine will use RAM as a cache, and it knows more about the data than you do.
Yes, so we'll talk about that too. So these are the basic operational characteristics. First is, up to a terabyte of RAM, you can hot expand, hot shrink, whatever. You can mix and match flash and RAM in a cluster. Now, from I know we haven't talked about operationals, which is, my next thing, but again, first trying to finish the specs part. And so from a where the industry stands point of view, we find this very important and interesting, is that the industry currently stands at a single server being able to do 1.5 terabytes of RAM. Intel has already announced chipsets that do 6 terabytes of RAM. And so the real question is, well, what do you do with 6 terabytes? And this is one of the answers. Again, I'll go into the operations part, in a second.
Crazy
But
expensive.
Yeah, as Bob points out, there's always the divide whatever Intel says by 2 because the DIMMs for that cost 10
Yeah,
times as
16
much.
gig DIM
Yeah.
is $200. A 32 gig DIM is $800.
Right.
So
Yeah.
it's really 3 terabytes of RAM in 96
Yeah.
DIM sockets. But yeah,
But that's still
Right.
that's still a lot.
still a
So,
metric boatload.
Humongous amount of RAM.
Yeah.
And so, and then we actually early on in our cycle, actually when we were doing FAP 1.0, we got some feedback from customers, and actually this goes back to your point, Justin, is that some of the guys we were working with had 400 hosts in their environment, and so he's like, well, what am I going to do? I'm going to open up all these hosts to add a SSD or a flash
Exactly.
device.
Yep.
But the same guy has 256 gigs of RAM in the host,
Mm-hmm.
and a lot of it is free. And so I said, why don't I start there? And so this is a great way for a mid-range server system, something that has a respectable amount of RAM. This is not something that you do on a 4 gig home lab machine that you have, but when a system has a respectable amount of RAM, there are many workloads that will actually do just fine with, say, whatever 10 or 20% of RAM actually dedicated to storage acceleration, the rest dedicated to running virtual machines. We have some, empirical data on what different workloads consume in terms of RAM footprint. And then we'll also answer, while we are at it, your other question is, can a database do caching better than us?
We've got a question from Twitter about, can you select which VMs go to which tier, flash or memory?
You can select which VMs go to which tier, flash or memory, but only by doing one thing, which is you separate out the 2 flash clusters. So you can make a all RAM flash cluster, and you can do a
Or a memory?
all memory flash cluster.
But if you mix and match, it's
If you
just-
mix and match, then you lose that control.
Okay,
yeah.
but the FAP will actually do auto tiering within those 2 tiers, essentially, because RAM will be quicker than flash.
RAM will be quicker than
So
flash, yeah.
there will
for
be
sure.
some kind of auto tiering that happens within FVP.
Mhm.
Okay.